You are already doing the right things. You cleaned up your diet, you cut the processed food, maybe you started walking every morning before breakfast. You feel leaner, you feel better, and your doctor told you your numbers are improving. Here is what nobody told you: the fat that is quietly killing you, the fat wrapped around your liver, your pancreas, and your intestines right now, is not responding to any of that. Not because you are not trying hard enough. Because visceral fat, the fat stored deep inside your abdominal cavity, operates on a completely different biological system than the fat you can pinch on your waist, and that system has a master regulator that almost no mainstream health content ever names directly. It is not calories. It is not steps per day. It is a molecule called interleukin 6, and in the next 14 days, your body is either producing it in quantities that keep your visceral fat locked in place, or it is not. The difference comes down to three biological levers that most people above 50 have never been told exist. Let me be precise about what visceral fat actually is, because the popular understanding is wrong in a way that makes it harder to address. When most people hear the word belly fat, they picture the layer of softness under the skin of the abdomen. That is subcutaneous fat. It is the fat you can grab. It is metabolically irritating and cosmetically visible, but it is not what shortens your life. Visceral fat is different in structure, location, and biological behavior. It sits behind the abdominal wall, surrounding your internal organs. You cannot feel it from the outside. You cannot see it in a mirror. A person can look relatively lean and carry a clinically dangerous amount of visceral fat. A person can be overweight by every conventional measure and carry a relatively modest visceral fat burden. The two are not the same thing, and treating them with the same interventions is one of the fundamental errors in mainstream dietary advice. Here is what makes visceral fat uniquely dangerous and the mechanism that almost nobody in the popular health space explains with any precision. Visceral fat is not passive storage. It is metabolically active tissue. It functions more like an organ than a fat depot. Visceral fat cells secrete signaling molecules called adipokines directly into the portal vein, the blood vessel that drains directly into the liver. This is the critical anatomical detail. The liver receives this chemical flood before any other organ does. Among those adipokines, two are particularly destructive: interleukin 6 and tumor necrosis factor alpha. A 2012 study published in the journal Obesity Reviews by researchers at the University of Edinburgh found that visceral adipose tissue secreted approximately 3 times more interleukin 6 per gram of tissue than subcutaneous fat. 3 times. Same body, same person, completely different biological output depending on where the fat is stored. When interleukin 6 floods the portal circulation and reaches the liver, it activates a hepatic inflammatory cascade that promotes insulin resistance in liver cells specifically, elevates C-reactive protein, one of the most reliable markers of systemic inflammation measured in clinical settings, and triggers the liver to increase its output of very low-density lipoprotein particles, the precursor to the small, dense LDL particles that embed in arterial walls and initiate cardiovascular disease. The people above 50 who have had a cardiac event without obvious risk factors were often carrying significant visceral fat loads that never showed up on a standard physical exam. According to data from the National Institutes of Health, approximately 35% of American adults carry clinically elevated visceral fat, and that number climbs steeply after the age of 45, particularly in people who maintain a relatively stable body weight, but experience gradual redistribution of fat from subcutaneous to visceral depots across decades. This redistribution is not a failure of willpower. It is a hormonal shift with a documented biological mechanism that accelerates specifically after 50 and is driven by 3 compounding variables I am going to walk you through one at a time. Because the invisible villain in this story is not the food you eat. It is the internal hormonal environment that determines where your body stores the energy from that food and how stubbornly it holds on to what is already there. The first variable is cortisol, not the cortisol of a stressful moment at work. The chronic, low-grade cortisol elevation that comes from disrupted sleep, inflammatory diet, social stress, and metabolic dysfunction compounding across years. Research from the Karolinska Institute in Stockholm, published in the journal Psychoneuroendocrinology, documented a direct relationship between urinary cortisol, metabolite output, and visceral fat accumulation that was independent of total body weight. people who were not overweight by conventional measures, but who showed elevated cortisol markers, carried significantly more visceral fat than their weight-matched peers with normal cortisol profiles. The mechanism is specific. Visceral fat tissue expresses a particularly high density of a receptor called the glucocorticoid receptor. This receptor is the molecular docking station for cortisol. When cortisol binds to glucocorticoid receptors in fat tissue, it promotes the differentiation of pre-adipocytes, fat cell precursors, into fully mature fat cells. But it does not do this uniformly across all fat depots. Visceral fat has roughly 4 times the density of glucocorticoid receptors compared to subcutaneous fat in the same person. This is not a minor structural difference. It means cortisol is, biologically speaking, a targeted instruction to preferentially grow visceral fat. Every chronic cortisol elevation your body experiences is a signal that hits visceral fat 4 times harder than it hits the fat anywhere else. The second variable is insulin resistance, and the way it connects to visceral fat is the reverse of what most people assume. Most conventional messaging implies that you gain weight first and then develop insulin resistance as a consequence. The research tells a more uncomfortable story. A 2019 analysis from researchers at Harvard Medical School, published in Cell Metabolism, traced the temporal sequence in longitudinal cohorts and found strong evidence that visceral fat accumulation and insulin resistance develop together in a mutually reinforcing loop, rather than one simply causing the other. Visceral fat drives insulin resistance through the interleukin-6 pathway I described. Insulin resistance, in turn, creates a hormonal environment in which the body cannot efficiently mobilize stored fat for energy. The fat cells effectively stop listening to the signals that should be triggering fat release. The technical term is lipolysis impairment. The practical consequence is this: a person with meaningful insulin resistance can be in a caloric deficit and still fail to lose visceral fat at anything close to the expected rate, because the machinery responsible for releasing stored fat has been desensitized by the very inflammation the visceral fat was producing. You're trying to empty a warehouse while the loading dock controls are jammed, cleaning up the diet, eating less, walking more. All of those things move the inputs. None of them fix the control panel. The third variable is one almost nobody addresses, especially for people above 50. The progressive decline in 2 hormones that are the body's primary regulators of fat distribution: growth hormone and testosterone in men, and growth hormone and estrogen in women. Both fall across midlife in patterns that are well documented but almost never discussed in terms of their direct effect on where fat is stored, rather than how much fat is stored. A 2002 study from the Journal of Clinical Endocrinology and Metabolism found that adults with clinically low growth hormone had visceral fat deposits that were 50 to 60% larger than age-matched controls with normal growth hormone levels. 50 to 60%. The researchers found that growth hormone replacement in deficient adults produced measurable visceral fat reduction within 12 weeks, independent of any changes in diet or exercise. That research was on clinically deficient populations, not healthy aging adults, but it points to the mechanism that matters. Growth hormone actively directs the body towards subcutaneous rather than visceral fat storage, and it amplifies the rate at which visceral fat is mobilized as fuel. When growth hormone declines with age, the directional signal changes. The same caloric surplus goes to a different address. The same fasting state produces less visceral fat mobilization than it would have a decade earlier. Here is what this means practically. If you are above 50 and you have been doing all the right things, eating cleaner, moving more, cutting the alcohol, sleeping better, and you are not seeing the visceral fat shift, you are not doing it wrong, you are treating a target that has 3 distinct biological locks with one key. The cortisol lock, the insulin resistance lock, and the hormonal decline lock all need to be addressed in a specific sequence for the 14-day shift to work. That sequence is the protocol I will hand you at the end of this video. But before I do, I need to walk you through what is happening inside your body during the critical window between day 1 and day 14, because the biology of visceral fat reduction is not linear. There is a threshold phenomenon buried in the research that explains why so many people give up in the first week believing nothing is working, when in fact the most important metabolic shift of the entire process was about 72 hours away. That shift involves an enzyme called adipose triglyceride lipase. the molecular machinery that breaks fat molecules stored in visceral fat cells apart into the free fatty acids your body can then burn for fuel. And the signal that activates it is not about what you eat or when you fast. It is about a specific type of cardiovascular stress that your heart needs to produce consistently across a 14-day window. The research behind that signal and exactly how much is required is where we go next. Before I explain what happens day by day inside the 14-day window, I want to address something the mainstream fitness industry has consistently gotten wrong about visceral fat reduction. The calorie in, calorie out model is not false. It describes thermodynamics accurately. What it fails to describe is the hormonal environment that determines which compartment of body fat those calories come from. You can be in a caloric deficit and lose predominantly lean muscle while visceral fat remains essentially untouched. A 2011 study published in the journal Obesity by researchers at McMaster University examined body composition changes in overweight adults placed in equivalent caloric deficits through diet alone versus diet combined with specific exercise. The diet-only group lost weight, but their visceral fat reduction was 45% lower than the group that added the specific exercise component. Same caloric deficit. Radically different visceral fat outcome. The exercise variable was not about burning more calories. It was about generating the hormonal signal that visceral fat responds to, and caloric restriction alone does not produce. That signal is natriuretic peptide. Here is the mechanism. Your heart is not just a pump. It is an endocrine organ that produces hormones. Atrial natriuretic peptide and brain natriuretic peptide are released by cardiac muscle cells in response to mechanical stretch. Specifically, the stretch produced when your heart chambers fill with a larger volume of blood than they handle at rest. This happens during sustained cardiovascular exercise at moderate intensity. When your heart rate is elevated and maintained for a specific duration, your atria and ventricles are handling significantly higher blood volumes per minute. That mechanical load triggers natriuretic peptide release into the bloodstream. These peptides bind to receptors on fat cells. But visceral fat expresses significantly higher concentrations of the natriuretic peptide receptor called NPCA than subcutaneous fat does. A 2005 study from the journal Arteriosclerosis, Thrombosis, and Vascular Biology by Lafontaine and colleagues at the Institute of Metabolic Diseases in Toulouse, France confirmed that natriuretic peptide-stimulated lipolysis was 2 to 3 times more potent in visceral fat compared to subcutaneous fat in human subjects. The heart produces a molecule. That molecule targets visceral fat preferentially, and it is produced in meaningful quantities only when you exercise in a way that generates sufficient cardiac volume load. The right type is not high-intensity interval training, which is what most fitness content recommends. This is the mainstream betrayal buried inside the exercise for fat loss category. High-intensity intervals produce a significant cortisol spike. For people above 50 with already elevated baseline cortisol, adding a cortisol spiking exercise protocol 3 to 4 times per week does not reduce the cortisol lock on visceral fat. It compounds it. A 2014 analysis in the journal Hormones and Behavior by Hackney and colleagues at the University of North Carolina at Chapel Hill documented that high-intensity exercise in middle-aged adults with baseline cortisol dysregulation produced post-exercise cortisol elevations that remained detectable 6 to 8 hours after the session. 6 to 8 hours of elevated cortisol activating glucocorticoid receptors in visceral fat, 4 times as densely packed there as anywhere else. The exercise that generates natriuretic peptide at volumes sufficient to drive meaningful visceral fat lipolysis without spiking cortisol dangerously is sustained moderate intensity cardiovascular work, specifically maintaining a heart rate between 65 and 75% of your maximum for a minimum of 35 continuous minutes. Below 65% cardiac volume load is insufficient to generate meaningful natriuretic peptide release. Above 75% cortisol begins climbing at a rate that partially offsets the lipolytic benefit. The window between 65 and 75% is where the biology actually works for this specific purpose. Now let me walk you through the 14 days in a way that maps what is actually changing inside your body because the timeline is counterintuitive. On day 1 and day 2, nothing measurable is happening in your visceral fat tissue. The natriuretic peptide signal is being generated if you executed the first session correctly, but the visceral fat lipolysis machinery needs repeated signaling before it ramps up. Think of it as sending a message to a warehouse that has been running in lockdown mode for years. The message arrives, the receiving department reads it, but nobody has cleared it with management yet. On day 3, something changes. A 2018 study published in the American Journal of Physiology, Endocrinology, and Metabolism by researchers at the University of Copenhagen found that 3 to 4 consecutive days of moderate intensity aerobic exercise produced a measurable upregulation in the expression of adipose triglyceride lipase, specifically in visceral fat depots, not subcutaneous fat, visceral fat. The gene expression for the key lipolytic enzyme shifted upward after 3 to 4 days of consistent signaling. This is the threshold event. The fat release machinery is not gradually improving from day 1. It is stepping up at approximately the 72-hour mark. Day 1 and day 2 feel identical from the inside. Day 3 is biologically different in a way you cannot feel, but the science can measure. Between day 4 and day 7, insulin sensitivity begins improving in a pattern distinct from longer-term dietary changes. A 2017 meta-analysis published in Diabetologia by Jellyman and colleagues at the University of Leicester synthesized data from 50 randomized controlled trials and found that moderate intensity continuous exercise produced significant improvements in insulin sensitivity within the first week of consistent practice. When insulin sensitivity improves in the liver and muscle tissue, the insulin resistance that was keeping your fat mobilization machinery jammed begins to loosen. The loading dock controls start responding again. For someone above 50 who has been accumulating low-grade insulin resistance for years, even a partial restoration of hepatic insulin sensitivity changes the metabolic environment substantially. Less insulin needs to be released to manage the same glucose load. Lower circulating insulin means less suppression of hormone-sensitive lipase, the other key fat-releasing enzyme, particularly in visceral tissue. The cortisol, the insulin resistance, and the natriuretic peptide pathway are all moving simultaneously during this window. Connected mechanisms responding to the same behavioral inputs in a sequence the research describes consistently. Between day 8 and day 11, a separate process activates that has nothing to do with exercise and everything to do with what happens to visceral fat's inflammatory output as it begins shrinking. As visceral fat cells reduce in volume, their secretion of interleukin-6 and tumor necrosis factor alpha decreases. That is the expected finding, but a 2020 paper in Nature Metabolism by Spara and colleagues documented something structurally more important. The reduction in inflammatory adipokine secretion from visceral fat produces a measurable improvement in glucocorticoid receptor sensitivity in the remaining visceral fat tissue. In plain terms, as visceral fat shrinks and produces less inflammation, the remaining visceral fat cells become less reactive to cortisol signals. The 4 times denser glucocorticoid receptor density that was making visceral fat so responsive to cortisol begins to work in your favor. This is the biological explanation for why visceral fat reduction appears to accelerate rather than decelerate in the second week of a correctly executed protocol. The first week breaks the initial threshold. The second week benefits from a self-reinforcing reduction in the very inflammation that was holding the fat in place. The warehouse is not just opening its doors. The manager is starting to cooperate. Between day 12 and day 14, I need to be honest about what you will and will not see. You will not see visible changes in your abdominal appearance that are significant enough to verify with a mirror. Visceral fat does not show in a mirror. The reduction that occurs in a well-executed 14-day protocol is measurable by imaging and by inflammatory biomarkers, not by how your pants fits. A 2009 study from the journal Metabolism by Shukri and colleagues at the Cleveland Clinic examined visceral fat changes in overweight adults following a 14-day exercise intervention and found that visceral fat area measured by CT scan reduced by an average of 11% in participants who adhered to the protocol, while subcutaneous fat showed no statistically significant change in the same period. 11% in 14 days, not a cosmetic change you can see. A structural change in the tissue that is driving your inflammatory and metabolic dysfunction. For someone above 50 managing elevated fasting glucose, blood pressure trending upward, or cardiovascular risk markers moving in the wrong direction, 11% visceral fat reduction in 2 weeks is the beginning of a reversal of a process that was going to compound into something serious over the following 5 years. I want to spend a moment on something personal. A few years before I understood any of this mechanistically, I was doing what most people in their 50s do with health research: eating clean, walking daily, following my doctor's recommendations, and feeling good about my discipline. My fasting glucose was creeping upward. My waist circumference was not changing. I did more of the same, and nothing changed. It was not until I understood that visceral fat was running on a completely different operating system that the approach shifted. The protocol I will give you in the final chapter is the applied form of the mechanisms I have been walking you through. Your physician's supervision is not optional, it is the baseline. But the 14-day window is not arbitrary, it is the minimum time frame for the biological sequence of adipose triglyceride lipase upregulation, insulin sensitivity improvement, and inflammatory cell reduction to complete one full cycle. Shorter than 14 days and you have not crossed the threshold where the process becomes self-sustaining. 14 days is when the machinery shifts gears in a way that makes the next 14 days meaningfully more effective than the first. That is where we go in the final chapter. The protocol is called the VFR protocol. 3 components. Each one has a specific number attached to it. Each one addresses one of the 3 biological locks I identified in chapter 1. The cortisol lock, the insulin resistance lock, and the hormonal decline lock. There is one error that invalidates all 3 if you make it, and it is more common than any of the 3 steps. I'm going to give you the error first. The error is sequencing the 3 components in the wrong order. People read about cortisol, read about exercise, read about diet, and implement whichever feels most accessible first. The biology does not care about accessibility. The natriuretic peptide pathway requires low baseline cortisol to operate at full efficiency. The insulin resistance improvement from exercise is significantly amplified when it occurs in the context of a dietary change that precedes it by 48 to 72 hours. And the hormonal component, the third lever, is rendered almost inert if the inflammatory environment from visceral fat has not already been partially disrupted by the first 2. The sequence is not a preference. It is the order in which the biological locks open. Get it wrong and you are pulling on the right keys in the wrong combination. Now the V in VFR stands for volume anchor. This is the exercise component and the specific number is 35. 35 continuous minutes of moderate cardiovascular exercise, heart rate between 65 and 75% of your maximum. Perform daily for the first 7 days and then 5 days per week for the remainder of the 14-day window. A 2013 study published in the European Heart Journal by Moreau and colleagues at the French National Institute of Health and Medical Research found that meaningful circulating atrial natriuretic peptide elevation appeared at approximately the 30-minute mark of continuous moderate intensity cardiovascular work and continued rising through the 45-minute mark. Below 30 minutes, cardiac volume load was insufficient to generate the threshold release. The 35-minute target sits inside the confirmed effective window with a 5-minute buffer against early cutoff. For people above 50, the heart rate calculation matters more than the activity type. Walking, cycling, swimming, elliptical, the modality is secondary. Your maximum heart rate can be estimated using the formula 220 minus your age. If you are 55, that gives a maximum of 165 beats per minute. 65 to 75% of that is approximately 107 to 124 beats per minute. Most people walking at a casual pace operate below this range. Most people jogging or doing high-intensity intervals operate above it. The zone requires a heart rate monitor or fitness tracker to execute correctly during the first week until you can recognize the effort level by feel. The F in VFR stands for fasting fuel window. This is the dietary component, and the specific number is 14. 14 grams of fiber consumed in the meal, immediately preceding your exercise session each day. The mechanism runs through short-chain fatty acids. When dietary fiber reaches the colon, gut bacteria ferment it and produce butyrate, propionate, and acetate. A 2019 clinical trial published in Cell Host and Microbe by Zhao and colleagues at Rutgers University found that increasing dietary fiber to target short-chain fatty acid production produced measurable improvements in insulin sensitivity within 2 weeks. Butyrate acts on receptors in the gut lining that signal the pancreas to modulate its insulin secretion pattern, reducing the amplitude of post-meal insulin spikes without reducing glucose clearance. Insulin still does its job, It just does it with less volume. Less insulin volume means less suppression of hormone-sensitive lipase. Less suppression means more visceral fat release per hour of fasting or exercise. 14 grams of fiber before exercise is not a number that requires dramatic dietary restructuring. One medium avocado contains approximately 10 grams. A cup of lentils contains approximately 15 grams. 2 tablespoons of chia seeds contain approximately 10 grams. The pre-exercise fiber meal should be timed approximately 90 minutes before the session starts. Enough lead time for gut signaling to begin without the exercise session competing with digestion for blood flow. The R in VFR stands for reset window. This is the sleep component, and the specific number is 90. 90 minutes of sleep before midnight, counted from when you actually fall asleep. Growth hormone, the hormone that directs the body to preferentially mobilize visceral fat over subcutaneous fat, is released in pulsatile bursts during sleep, with the largest burst occurring in the first 90 minutes of deep slow-wave sleep. This is documented in foundational work by Van Cauter and colleagues at the University of Chicago, published in the Journal of Clinical Endocrinology and Metabolism. The critical detail: slow-wave sleep in the first cycle of the night is both the deepest and the longest slow-wave segment of the entire sleep period. If that first 90-minute window occurs before midnight, it aligns with the body's natural circadian peak in growth hormone pulse amplitude. After midnight, the same slow-wave sleep produces a measurably smaller growth hormone release because the circadian peak has already passed. This is not about total sleep duration. A person sleeping from midnight to 8 in the morning and a person sleeping from 10:30 to 6:30 both get 8 hours. The growth hormone release from those two sleep windows is meaningfully different. For people above 50, this matters more than it did at 35 because growth hormone pulse amplitude has already declined with age. The pre-midnight deep sleep window is where the hormonal environment tips from the direction of visceral fat accumulation toward visceral fat mobilization. 90 minutes before midnight is not a suggestion about bedtime. It is a specification about where in your circadian clock your first deep sleep cycle lands. Here is the sequence. Day 1 through day 3. Begin the fiber first meal 90 minutes before exercise. Execute the 35-minute moderate cardio session in your heart rate zone. And implement earlier sleep timing so your first 90 minutes of deep sleep occurs before midnight. These 3 inputs run concurrently from day 1. The cortisol lock begins loosening because moderate exercise without cortisol overshoot, combined with earlier deep sleep, starts reducing the chronic cortisol elevation that has been preferentially feeding visceral fat for years. The insulin resistance lock begins releasing through the short-chain fatty acid pathway, and the moderate exercise insulin sensitivity improvement that Jellyman's meta-analysis documented within the first week. The hormonal lock begins opening through the pre-midnight growth hormone pulse firing in its circadian peak window. Between day 4 and day 7, nothing will look dramatically different. Your waist will look the same. The scale may not have moved. This is expected. What is happening invisibly is exactly what the University of Copenhagen data showed. Adipose triglyceride lipase expression in visceral fat has upregulated. The fat release machinery has shifted into a higher gear. The people who quit between day 4 and day 7 are quitting at the precise moment the biological machinery has just been primed to accelerate. Between day 8 and 14, the inflammatory self-reduction cycle described in the second chapter is running. Visceral fat cells are smaller, secreting less interleukin-6, generating less insulin resistance, and becoming less reactive to cortisol. The 3 locks are not just unlocking in sequence. The act of opening one is making the others easier to open. One more layer for people above 50 specifically. Consistency of timing matters as much as the behavior itself. A 2020 paper from Sachin Panda's lab at the Salk Institute, published in Cell Metabolism, found that individuals whose behavioral timing varied by more than 60 minutes across days showed significantly lower metabolic benefit than those who maintained consistent timing. Your circadian clocks in the liver, the adrenals, and the fat tissue itself are calibrating their receptor sensitivity based on repeated behavioral timing. Show up at the same time with the same inputs for 14 days, and the system amplifies the response. Show up randomly, and the system treats each session as a novel input rather than a reinforcing signal. The VFR protocol is most powerful when the exercise window, the fiber meal, and the sleep anchor happen within 60 minutes of the same time each day across the full 14 days. the mistake that invalidates the entire protocol. Executing the volume anchor and the fasting fuel window correctly, but treating the reset window as optional because the sleep timing change requires the largest behavioral shift. Removing the reset window does not give you 2/3 of the benefit. It keeps the third lock closed, the lock that determines whether the fat being mobilized by natriuretic peptide and improved insulin sensitivity is primarily visceral or primarily subcutaneous. Without growth hormone directing the mobilization, the body will still release fat. It will be less targeted toward the visceral depot. You do the hard work of 14 days of consistent exercise and dietary adjustment and get modest subcutaneous improvement rather than the structural visceral reduction the protocol is designed to produce. The sleep component is not the add-on. It is what makes the first two components hit the right target. If you are going to start the VFR protocol this week, comment VFR below so I can track who is actually running this. I read every comment, and in 2 weeks I will be back with data on which specific fiber sources the community is finding most practical to hit the 14-gram pre-exercise target, because the numbers from people who have been running this have been more interesting than I expected. If this is the kind of content you want, no motivational speeches, every claim sourced, mechanisms not marketing, subscribe. 1 video a week every week. The mechanisms quietly running your biology are not complicated once someone takes the time to explain them correctly. That is what this channel is for.